direction. You're recording? Did you say something? Should be right now. Okay, so let's go through this question together real quick. First and all, let's say that a car of mass 1,500 kg traveling at 20 meters per second collides head-on, this is your keyword, collides head-on with another lorry moving at 25 meters per second. The lorry has a mass of 900 kg. If the collision reduced the speed of the lorry from 25 to 20 meters per second, what is the velocity of the car after impact? Now, first and foremost, guys, you notice that I highlighted this word. What does the word head-on collision mean? Right. If it's a head-on collision from here, first things first is one object must be moving towards the right direction and one object must be moving towards the left direction. In terms of momentum, what does moving left and right mean again? Right is negative and left is positive. Good. You could associate the right to positive and the left as negative, or you could do it the totally other way around. You could go left as positive and right as negative. But it doesn't matter which one you do, as long as you know that if they are in opposite directions, one will be positive and one will be negative. Excellent. Right. So from here, if I look at this information, obviously, if I start labeling it, this is going to be my M1, right? And this is going to be my U1. This is my U2 and this is my M2. This is supposed to be my B2, right? And from here, since I have so much information, I'm obviously going to use the principle of conservation of momentum, right? Which states that total momentum before collision must be equal to total momentum after collision, right? The formula is supposed to be M1U1 plus M2U2 is equals to M1V1 plus M2V2. So I substitute all the information in right now. It's going to be like 1,500 multiplied by 20 plus with my 900 multiplied by negative 25, right, is equals to same thing like 1,500. I don't know what's the car of the speed, so I just put V1 plus with 900 multiply by negative 20, right? Because it only slowed it down to 20, so I must assume that it is still moving in the same direction. From here, try to redo your calculation again and see if you can get 17. Oh, got it? Evan, you got it? Yeah. Hey, Shinjin, I want to ask, right? When I minimize this, will you still be able to see my face? Do you see my face right now? Oh, so it doesn't matter if you... This thing doesn't really matter, it's like... Okay. Yeah, I thought like if I minimize this thing, then the face won't show. Whatever. Okay. Then after that, moving on. What other question could you not do? Any other questions that you did not get the same answer? Okay, I got one of them. Which one? Question 9. Question 9. Okay, let's look at question 9 first. This is literally almost the same thing as what we did just now, right? It says here, a car of mass 1,000 kg is traveling at 20 meters per second, collides with a car of mass 2,000 kg traveling in the opposite direction in 7 meters per second. So if I associate this as positive, then this one will be negative, right? Right. Then what is the velocity of both cars if they stick together? This is a keyword. What does this mean?
Inelastic collision.
Good. If it's inelastic collision, how will the formula morph? It will still be M1U1.
M2V2.
U2
U2
is equals to
is equal to M1 M1U1
M2U what? M1U1 M2V2 like that. Are you serious, bro? How will the formula morph? Oi, I told you this, right? Refer to your notes again. Tell me what would happen to the formula if they stick together. Xinyan, you're right already, by the way. You see?
M1V2.
U2. Are you serious right now?
Okay,
M1U2.
M
What is it? If they stick together, what's happening when they stick together? Think about it.
they both have the same velocity.
Oh, yeah, they both have the same velocity, right? So what would the formula be? Will that be like V1 plus M2 V2 or not? Is this possible? Will this be the correct formula or not if they stick together?
Yeah. No.
You know what does V1 and V2 mean, right? V1 means to say this will be moving at one speed, and V2 means to say this will be moving at another speed. Is this correct? No. How will the formula change into?
MV
M1
V
V and then M2?
M2 V.
Yeah, it's V, right? Because they are sticking together, Evan. Remember or not? Do this later on and see. You should be able to do it. And just when you do a calculation, make sure one is positive and one is negative. Okay. Xinyan, what do you get for question number 8? Do you happen to get 0.1? Negative 0.1. I think negative 0.1 is correct. Let me do the calculation. This answer is wrong, by the way. I think I said this in class, but this answer is wrong. Let me do it. A bullet have mass of 10 gram, which is 0.01 kg. It's fired with a rifle of 4 kg. So this is M2, let's say this is M1 now. The bullet is traveling forward, so this is V2. What is the recoil? You're looking for V1. So 0 equals to M1V1 plus M2V2. The 0 is because before collision, no one is moving, right? So it's just going to be 0 straight away. And it's going to be like 4 multiplied by V1 is equals to 0.01 multiplied by 40. So, yeah, plus. It's not equals, it's plus. It's plus here. Then from here, it will be like 4V1 is equals to 0.4, negative 0.4. Yeah. Then your V1 will be negative 0.1. Yeah, you're correct. Xinyan, you're correct. It is negative 0.1. You got number 9 already, Evan? Bro, we're lost, actually. This part here is which part of the equation? Which part of the equation? No, from here, which part is the equation? Oh. So whatever you found here, this is the representation of the first half, right? Then you still need to do your second half, right? Whereas you're working for the second half. Equal. Substitute your information. Wait a minute, how did you get this 1,500 here? Ah, oh, come together. Bye bye. Bye bye. Well, I think you are getting more and more confused as well. You do it, show me, do this. You do it. Shinyan, is there any other questions that you couldn't do from here? Everything else, do you get it correct already? Okay, you hold on a bit. This guy here is stuck on the last question. I need to make sure he knows how to do this before we continue on. But yeah, something bad I didn't know how to do. Yeah, you wait on. You give me give this guy 3 more minutes. Then after that we'll proceed. Hey, Kevin, let me tell you what to do. Hey, your calculation is very long, right? Label, you need all these things, right? Write down M1 equals to what, U2 equals, U1 equals to what number, M2 equals what number, equals number. M1 is how much? One. Two. U2. Why negative 20? Where did this negative 20 come from? Why 20? Why 7? But what did I say just now? Oh, so if this thing you already say is positive, meaning say you're associating this thing moving towards the right as positive already, right? If this thing is moving towards the left, then how? Oh. Then after that, you're looking for V, right? You have all the information here already, right? Write this formula down and substitute it one. Write this formula down here and substitute it one. Great, good. Substitute all the information in. Oh, okay. Equal. No, right equals first. Finish. No, not here. Here, continue. Your this line is only this color. Finish writing this. Equals. How much is it? M1. bracket B, you're looking for B, right? Plus. Show me the loading. Pressing error. This 6,000 is this half, right? How? 6,000 goes to how much? Then. How do you get the 2?
1000 times 2 plus 2000 should be plus 4000.
No, that's not how you're supposed to do the thing, right? Yo, this 2 is the one that you're looking for. You're not supposed to substitute it in again. You're actually supposed to do this row. You're supposed to, after this step, is 6,000 is equal to 1,000 P plus 2,000 P, right? How much is that? 1,000 P plus 2,000 P, how much is that? Oh. Then only you're looking for B, bro. This is your step, then you tell me it's 2. B what? B must be to B. They pack you. What's the units of velocity? You don't know. Meters second square. Meters per second square. Oh. What is it? Meters per second, bro. Wait. What is basic stuff? You must know one. You get this is how you look for this. Go back home. Okay? Don't say it loud. Alright, then next. Okay. Xinyan, tell me your answer for the ABC part. How much do you get for number 1? B, correct. Number 2, Donkey. That's wrong. Okay, everyone, look at question number 2 here. Now, if you look at question number 2 here, it says that a gas molecule strikes a wall of a container, the molecule rebounds with the same speed. Okay, this is a keyword. The molecule goes in like this, then rebounds at the same speed. Before anything happens, what happens to the kinetic energy and what happens to the momentum of the molecule? Now, you haven't learned the kinetic energy formula yet, but kinetic energy is half mv squared, okay? If the speed is the same and obviously the mass before and after colliding is the same, then obviously the kinetic energy really does stays the same. So it's either between C or donkey already. But the momentum changes. Why? Why will the momentum change? Even though the mass, the formula for momentum is mass times velocity, right? Mass would be the same and velocity would be the same also because they say it's the same speed. But how come the momentum changes? Why? Good, it is the direction. From here, we know that this is positive momentum and this is negative momentum. And because one is positive and one is negative, what happens is the momentum changes because momentum is a vector quantity. Energy is a scalar quantity. It only has magnitude only. You got what I mean? Yeah? Xinyan, you understand what I'm talking about? Yeah. And number 3, obviously, this one is. What's the answer for this, Xinyan? Moment. Moment? What's the formula for moment? Go. Oh, force times distance or force times distance should be in Newton meter. How do you get to Newton seconds? It is impulse. Why is it impulse? What's the formula? What's the formula for impulse again? Two formulas. Force times time, and the second one?
Force times. Force times.
Force times time is one formula. How about the second formula?
One V.
I have one in your head lah. Which one is it? MV minus MU right or not? How do we know this? You can derive it literally from the F equals to MA formula, remember or not? What do we do? What do we do to the A? So what?
A
Into
into V
and
U.
and
Minus U only.
right. Now after that, expand the bracket and you will eventually get back to here, right? Remember last week I told you guys this, you must remember the impulse formula. It is a must because you can literally derive it from F equals to MA. Okay? Next. Yeah, let's go through one question at a time, since some of you guys didn't do it. Okay, let's go through this question together, guys. It says that figure 2.1 shows a dummy of mass 70 kg used in a car in a crash test to investigate the safety of a new car. The car approaches a solid barrier at 20 meters per second. This is useful information. It crashes in the barrier and stops immediately. What's my initial velocity? What's my final velocity?
Initial is 20 meters per second, final 0.
Good. Calculate the momentum of the dummy immediately before the crash. What's the formula for momentum?
Momentum.
What's the formula for momentum?
Force.
Force. Mass times velocity, bro. Remember the elephant story or not? Remember the elephant story or not? It's mass times velocity, right? Why does the elephant has higher momentum than you? Because it has higher mass. Yeah, higher mass and higher velocity. And obviously from here it's literally 70 multiplied by 20, which is going to be 1,400. What's the units for momentum? What's the units for momentum? What's the units for momentum? Kgs meters per second. Excellent. Evan, why is the units kgs meters per second?
Mass is in kg and then it times
with the what?
Times meters per second.
What's this thing called? What's the name of meters?
Velocity.
Yes, it's velocity. It's because it's mass times velocity. Now after that, they say determine the impulse that must be applied to the dummy to bring it to the rest. Looking at this scenario here, the impulse formula is obviously mv minus mu, right? Because you don't have force, nor do you have time, right? And I know for a fact that is eventually the v will be 0 minus your 1,400, right? So your impulse here, you don't have to write negative 1,400. You can still write 1,400 kg meters per second, because here, this is the explanation, guys. If we say temperature goes from 0 degrees to 100 degrees Celsius, or 100 degrees Celsius to 0 degrees Celsius, it doesn't matter which one, the change in temperature is still 100, right? And this is why we don't write negative for impulse. Impulse is the change in momentum. Doesn't even matter if it's 1,004 to 0 or 0 to 1,004. We do not need to write the negative number here. But if you write the negative number, it's not wrong. You don't need to only. Okay? Name the deceleration. In the crash test, the passenger compartment comes to rest in 0.2 seconds. Calculate the deceleration of the passenger compartment. What's the formula for deceleration again, Ivan? V minus u over t. Isn't this acceleration?
Yeah.
So what's the formula for deceleration? How do you relate deceleration and acceleration?
Accelerate equals faster, deceleration equals slower.
Oh, it's opposite, right? So if it's opposite, what's the formula?
Negative.
But U minus V, bro. Remember or not? Everything I taught you before, now you cannot answer me anything.
Because I tend to change the working into my own design.
Yes, don't do that. Don't do that anymore already. And write your working in your question. What's the initial again? Shit. 20. So it's 20 minus 0 over 0.2, right? You get 100 meters per second square, Shinan. Oh, really? You were lost for this one? Oh, just remember the acceleration and deceleration is the exact opposite, and because they are the exact opposite, this one will change. Instead of final minus initial, it will be initial minus final. Remember, this one is important. Okay, then next question. Do you do this, Junior? No. Good. Tell me what should I do? Evan, look at this question right now. The seat belt and airbag brings the dummy to rest so that it does not hit the windscreen. The dummy has an average deceleration of 80 meters per second square. Calculate the average resultant force provided the mass is this. What formula should I use?
Force and distance. Force and mass. Mass times. Mass times velocity.
Mass times velocity. Why? What are you looking for? Mass times velocity is what formula? Oh, is this question asking for momentum? Shinyan, look at the information and tell me what formula should I use first. Yeah, it is mass times acceleration. Why? Why? Because look, oh, this is acceleration. Good, this is mass. And you're looking for force, right? The only formula that relates these three things together is the F equals to ma formula, right? Guys, I said this in the other class, I'll say this here again. Guys, look, every time when you're reading these questions, okay, pay attention, stop writing, listen to this. Every time when you do this kind of questions, you already identify it's going to be a calculation question already. The first thing you do is to identify your information. That's why I always tell you guys to label your information, right? I'm looking at this information, I have A and M already. You know you're the only one here, right, bro? If I have A and M, what other formula can I make? It's only the F equals to MA formula, right? If it's the F equals to MA formula, it's like literally, if I give you banana, you can make banana cake. If I give you carrot, you can make carrot cakes, right? Can I give you chocolate and ask you to make banana cake at all? It doesn't work that way, right? If today I give you this information, then you must use this formula to find your answer, right? Find it right now. Junyan, tell me how much is it as well? Yeah. Do you get this? Good. Then the final part is a concept question. Shinyan, did you answer this? Good. You have a chance to answer it accordingly later. It says that the deceleration of the dummy is less than the deceleration of the passenger compartment. Explain why this is a benefit or the safety of the passenger. I'll give you a hint now. It has to do with the deceleration being less. Why and how will the deceleration of the dummy when it's less than the passenger compartment benefit the passenger? You can relate it to a specific formula.
If the passenger compartment accelerates slower than the dummy itself, then it can form a part of protection when the resultant force hits zero.
Not exactly, but good try. Very good try. Not exactly what I'm looking for. What could be the reason? Give me a reason that
But
nothing to do with airbag. It's related to a formula. Guys, think about it. What formula is related to deceleration? It's only a few, right? It could either be deceleration is equals to u minus v over t. It could be deceleration, which is the formula for acceleration, f equals to ma. No other already. You are going to explain it in terms of either one of these two forces. Why, when the deceleration is less, it is a benefit for the passenger. Explain it in terms of either one of these formulas. Let's pick a guess first. Do you think we should use the first formula or the second formula?
First.
Okay, good. Why?
and I think I got what I'm supposed to do. I just don't know how to say it or put it in words. If if the initial time, if the initial force is more than the when the initial force is more than the
Shinyan, you want to give it a try? Which formula and why? First one or second one? The mass of the dummy, no, it's nothing to do with the mass. In fact, they don't say anything about mass here. Okay, I'll let you guys know. Okay, we're actually supposed to use this formula here. And the reasoning is very straightforward. You guys are like, when I look at you guys think about it, I can already tell that you're trying to relate to everything you know, but it's actually a very simple thing only. Guys, look at this formula. If today I say that the deceleration is less, can I say that this thing here is less also? Right, the deceleration or acceleration is less, right? The mass of the dummy is definitely not going to change, right? For sure, not going to change, right? So when a decrease in the deceleration, what's going to happen to the force? Yeah, the force is lower as well. So if I want to answer this right, a decrease in the acceleration of the dummy is beneficial because I will generate less force on the dummy during impact and thus sustaining less injury, right? This is one way I could answer it, right? Look here, force on impact is less sustained, likely to be less injured. Literally, don't overcomplicate it. Just think about it in the formula and think about, oh, how does this relate back to this here? Because ultimately, if it's safe, it's because the impact is not as much, right? And when impact is not as much, it must be because the force. So you're supposed to write something like this. A decrease in the deceleration produces less force during impact. That's what I stated here. Thus, less injury is sustained by the. Okay.
Understand why many people live with. The little thing I understood is that at the start of the semester, everyone has to do the science subjects and math subjects. After that, people just wanted to do business, economics, or something. They just switched instantly.
That's so dumb. Gave up already straight away.
For me, it's right from the start. I just thought of only doing physics.
Good. If you know what you want, excellent.
Because I knew if I want to be aeronautics, chemistry is not exactly important. But at least from what I know.
Definitely not. But you still need to know the basics.
Yeah, basic.
Because later on, if let's say you go into aerodynamics, if you go into aerodynamics, maybe you have to know the composition of the metals and how they bond in whatever way that may be tested. You need to know the basic,
Basics.
yeah, but you don't need to go into the detail like all the what bonds are, what's it called, the organic chemistry, all those things.
But I knew I needed that's to be.
You'll definitely need MS for sure, MS and physics, if you're aerodynamic. Okay, now, then the second question here. On figure 2.1 shows a hammer being used to drive a nail into a piece of wood. The mass of the hammer head is 0.15 kg. The speed of the hammer head hits is going to be this amount already. So this is mass and this is going to be my velocity. The speed, the time for which the hammer head is in contact with the nail is this amount. So this is the time. The hammer head stops after hitting the nail. Calculate the change in momentum. What's the formula, Evan? Change in momentum. What's the formula? Nah, me forget again. Yeah, what's that formula? Change in momentum.
Four times time. And we want to be so.
Does this look like change in momentum, or this one looks like change in momentum more? This is literally final momentum, and this is initial momentum.
Everyone's agree.
And you dare tell me this first? How much? How much is it? Shannon, how much do you get? Oh, did you not do this as well, Shannon?
I'm pretty sure you didn't get this as homework.
Nah, no way. I told you actually. No.
I went to the toilet when you said it, so maybe I saw it.
Hey, bloody hell, you left the bubble tea on the staircase right that day when you left. You want me to beat you? You want me, how hard do you want me to beat you? Huh?
600 newtons.
One more time you do that, I'll beat you good. What formula do you use, Shinyan? We found it already, yeah? How much?
You know, because I'm not doing this move, but I'm I was confused algebra with numbers.
What? Confused algebra with numbers, what do you mean?
It's like they no again instead of it.
$800. Is it 800? I don't think it's that big. How do you get 800?
Oh wait, shit, just realized. Okay.
How much do you get? It's not 800,
Yeah.
Hello, Xinyan. Why got divide by a time one? This one is what formula already, bro? This is literally, what you're doing is literally this, right?
1.199775.
1.199. How do you get 1.199? Tell me you're working.
0.15 times 8. That's 0.15 times 0.0015.
0.0015. Is it?
Oh,
This is your U, right? Is it? This U is in what does U represent again, Ivan? Tell me, what does U represent again? Initial what?
initial time.
Initial time. Initial what? Initial what? Velocity, Evan. This is initial velocity. What's the units of velocity? Is this 0.0015 in meters per second? Then how? Why can it be that? It should be 0. Why 0?
Because there isn't a range.
Oh, because initially it was 0, right? Then after that it smashed downwards to 8 meters per second. No. You know what I'm talking about, right?
Okay.
Does it make sense now, Ivan? Wow, you guys are quite bad at this chapter, I must say. We are gonna do more on this chapter, luckily. 1.2, you got it, Then after that, impulse. What's the answer for impulse? How to do it? And it's 1 mark only.
4 times 9.
You don't have force. 1 mark only. Oh, it's the same thing, right? So if it's the same thing, can I just write 1.2 here?
Yeah.
Because literally change in momentum is impulse, right? That's why there's 2 marks here and 1 mark here. So guys, you must understand how the question will be asked also, guys. They give you 1 mark here is because most of the time you do not need to do any calculation. But however, you need to know that change in momentum is impulse. And because change in momentum is impulse, whatever you write here, you write it back down here, it will be the exact same answer. Yes? And finally, Xinyan, this one you can find your F already. This is your 800, right? How to find the F here, Evan? What formula? What formula? As I say, you will forget your working. You continue to write numbers here. So next week, you will know this formula already, every one of this. How much?
200 divided by 2.3.
Why? What's the formula? See? You can tell me the number. The number will be nothing. What's the formula? Wait, this one here, house, right? You literally wrote this down, bro. This change. This thing is changing. I should. Which part of this change? The whole thing. It's okay, everybody. I was showing Xinyan this thing here that she did was wrong because I only want this part. That's why you put 0.15, which is your m multiplied by 2. Sorry, b minus your m multiplied by 2. This is why you got 1.2. And right now you're looking for force. Shouldn't you look for force with this whole formula? Now, I just do it. No, I see it by I said a lot of sense by then. Okay. Okay, right? Haven't get it, huh?
Yeah.
Last one before I throw you guys with more exercises. Yay. The engine of an unpowered toy train is rolling at a constant speed on the level track as shown in figure 3.1. The engine collides with a stationary toy truck and joins with it. Before the collision, the toy engine is traveling at 0.32 meters per second. Where should I label this? In the diagram, left or right? Which one? The toy engine is traveling at 0.32 meters per second. Where should I label this? Yeah, on the left one. This guy here is moving at 0.32. Now, why do I make it a habit to label my diagram? Is because if I look at the diagram and I see my writing, I know that, oh, okay, right now I know that this is the initial velocity. It is the initial velocity of the engine, right? And it says that the mass is 0.5 kg. Okay, I'll label here also 0.5 kg because that's what the information gives, right? Now, after that, they ask you to calculate the toy engine. Oh, sorry, this 0.5 kg is here, not the truck, it's the engine. This thing is 0.5 kg, right? Now, after that, they ask you to calculate the momentum of the toy engine before the collision. What's the formula again here, Evan, to get my 2 marks? How do I find the momentum of this thing here? Same question again, Evan. What's the momentum formula? F. Sorry, bro. Literally just say this, bro. What's the momentum formula, bro? What is it dependent on? Oh, so what times what right now? Yeah, it'll be 0.5 multiplied by 0.32, right? Literally, then bam, you get your marks already. I think it'll be 0.16, is it? 0.16, yeah. kg meters per second. Yes. Chinyan, you got this one right, should be easy. Then this one here is the one that most likely you did not get it. Did you get this one? The B for the speed? 0.2. Oh, very good. That is correct. Now, Evan, you have to tell me how to do this. Wait, Chinyan, you're done already? Oh, yeah. If you're done, right? I think I sent a file to the group chat, guys. I sent a file to the group chat. I think I sent it this afternoon. Yeah, oh, you printed already. Start doing that one. Where is it? Yeah. So start doing this one here. You can start doing it. Wow, I pen to Evan. My boy. Evan, my boy, what do we do for the next question? How do we do it? Read the question and tell me what to do. Is it here? Is it there? Is it because I said you were there? The point 15. Breathe. Okay. I tell you what. Ignore everything that I said. Breathe from the start again. Tell me. Label it onto your picture and show me. Total and almost. How much is the total truck in terms of mass and how much is the engine in terms of mass? 0.3 to what? 0.55.
0.32 for the unpowered, the collision and you're gonna work the station for.
What is 0.3 to and what is 0.3? Like,
Oh,
what do they represent?
acceleration.
Um,
Train 0.3.
the mass of the train is 0.3, okay, and then the mass of the truck is 0.5, is it? Is that what you got from the question? What does it say? Starting from the before the collision part.
Again, of the unpowered train is rolling and concentrating in the low track. Station 301. One, the engine provides the station to truck and join to the
Okay, that's a keyword there, right? What's the keyword for that first statement?
and join to
Good. If the joint it means to say is, underline that and put a note there, in elastic collision. Okay. So we know that they will join together, right? If they join together, what happens again? What happens to the
and one to one and two with two. With one and one v one and one v one substantive v two equals to and one v.
right on? Excellent, good. So you know in the back of your head, this formula is going to be used for sure already, because you say you don't together, right? We start on and make sure I analyze and extract the information. See before.
Before the collision, the toy engine is traveling 0.3 meters a second. The mass of the engine is
Okay, extract this information and tell me. What is this about 3 2 again? No, okay. Explain it in terms of the diagram, tell me.
0.32 is the speed of
Good. It's definitely not the mass. We say just now. Okay, then after.
the 0.5 is the
So while you copying and after I think the first mistake, you didn't copy that this should be here instead. Right, so like extract it away and put the 0.5 on that. Make sure you write your units so you know what's going on. Then the 0.2 then. Good. The 0.32 one then. What's your units? Good. Now looking at this, it looks more manageable, right? Than slowly extracting all the information here. Next thing I want to do, using the principle of conservation of momentum, find the speed of the joint engine here after which one is the keyword? What are you looking for?
after the collision.
Oh, good. After the collision, you're looking for the speed of the joint engine and truck, right? So how to do? YV unit start. Is it V or U first? Is that a U or V? No. Right, roughly, huh? Good. Now you extract all the information one by one, right? It's the initial velocity of the engine. Ah, sure, bro. Look at the diagram again. Oh, but good. Don't put plus sign, make sure I'm going to write it. Find me a V. Your diagonal angle. Okay, how much is the? Oh, okay, right. Okay. So how do we do it? Good. Good. Excellent. See what's happening at the figure 0.16. And that's not the way to do it. If that's the bigger number, you have to do it out. Okay. So what's the algebra way to do it? Instead of guessing. Okay, let me give you a simple start. And then explanation start, right? I want you to think. You know, 3 times 4 is 12, right? How do we treat this together? Which one do we? Okay. 3 is 15. Don't have anything of it. 5. 4. 3. Just 4. 3 goes to celebrate 4. Good. Good. And bring this away. Use this here. Instead of 3 and 4 is going to just be. Don't look at it. You can look at that. That really is good for us. Be there. How do I get these now? You understand the concept. Next time, if you have any exam, if you are lost in this kind of scenario, right, just put this number and compare. This thing and this thing is this and this, right? This 12 is essentially going to be this, right? So if I want to find B, how do I make 3? It sure as hell won't be divided by 12, right? If it's sure as hell won't be divided by 12, then it should be 12 divided by 12, these things should be brought down here. You got me. Okay, let me finish some homework for you to do. Oh, Shinya, sorry, I did not see your message. What do you think? When we're doing working, right, do we have to write down the units? No, when you're doing the working, you don't write down the units because it will take too long already. So. Jesus Christ. So many impulse formula can be F equals to MA. No, impulse formula. Okay, pay attention, everyone. What's the difference between the force formula and what's the difference between the impulse formula? Now, We know impulse has two formulas, right? Impulse is either going to be force times time, or impulse is either going to be change in momentum, right? Is what I told you guys, right? Since I know that this is impulse and this is impulse, we can equate both of them together. We say that Ft is equals to mv minus mu, right? This is impulse and this is impulse also. But most of the time, because we are human beings, right? We won't remember, we won't purposely go and remember, oh, Ft equals to mv minus mu. No one will remember this. So what I told you to do is, instead of remembering the formula, you can derive it from the F equals to ma formula, right? Because we know that A is equals to V minus U over T ma. Then from here, I expand the bracket. I say that F is equals to mv minus mu over T lah. Right, and I replace this back upwards here, it will be Ft equals to mv minus mu, right? Now, the impulse formula and the force formula are definitely two different things, but we can derive the impulse formula by using the force formula. You get what I mean, Shinyan? Is that what you're trying to say? Or is that what you're trying to ask? Yeah. So the force formula is not the same as impulse. The force formula can derive to the impulse formula. But yeah, this could also be the force formula also. Yeah. How's that? Good, excellent. Okay. Oh, wow. Remember to do refer to the notes. Make sure you know the basic formulas first. Oh, right, get it okay.
Oh, shit. This is the UN.
Sorry.
Because remember talking about the everyone thing where we go into things.
Yeah.
If you did that, you're need to go to the online version of it.
We need to go. We don't need to go to the physical version.
Yeah, but you can do both, but the online is considered free.
Oh, okay.
Yeah. Obviously, you usually have to pay like 20 USD.
Oh, it's okay. It's fat USD.
Yeah.
This. Yes.
It's almost time already.
Oh,
Yep, then I think.
But next week, for question one, we did just now, can I explain how to do it? Actually, now, which one? Xinyan, which question you're talking about? This one here. Now,
what the hell is my grade just found an excuse to tell this kid?
what?
My grade, like, because they give up my name, my grade immediately tell an excuse just to say why my some shit today.
Yeah, but it feels like you are not focusing today, Ahmed. It's like your mind is somewhere else today. It definitely feels that way. Please make sure it's just today and not every day. Because yeah, it will be counterproductive. If that's the case.
At least I was a paper.
Yeah. Anyways, since both of you guys are here, yeah, we'll stop class here today lah. Everything else is gonna be homework, guys. You'll see that some questions are the same. It is definitely expected that since it is the same question, you know the same answer without referring to it, guys. Please make sure you do it. Okay, guys, I'm gonna stop here today. If you have anything, just send me a message. Okay.
We can take this, I can.
Okay, welcome. Yeah, sure. Thoughts is yours.